Hi everyone, my name is Patrick. I'm a TA for your operating systems course, and today I'll be going over GitHub and a brief introduction to XINU operating system, as well as the assignment 3, which is your synchronous serial driver assignment, and I'll give you guys some tips on that. So first thing you want to do is open github.com, and if you don't already have an account, you can click sign up. I already have an account, so you're going to want to fill in this information here, and then click create an account, and then we'll go to step 2. So once you set up your account in the first step, you'll be taken to step 2. So your plan, you're just going to want to click the free one. If you were in lab on Friday, you'll know we told you to choose the pro account, which you can get for free by being a student and entering your edu address, and I think you also have to email a picture of your ID or something like that. But we only thought this was a requirement because as of a few weeks ago, the private repositories option was only available for pro accounts, but recently they just made it available for private accounts. So since that was a recent change, we weren't really aware of that. It's always been that the pro accounts only had access to the private repositories. But just click free account and click continue, and you can skip this step, and you'll be at your dashboard. So I signed into my actual GitHub account, and so to start a new repository, you won't have this green button yet. You'll have something that says create a repository in the left hand side, or you can click this plus up here on the top right and click new repository. So I'm just going to call this XINU homework 3, and you're going to definitely want to make this private. So a private repository means no one can look at your code except for you and your OS partner, who you can assign in your repository. So definitely make sure private is ticked here, and hit create repository. Alright, so now we have a repository. Alright, now that we've created our GitHub account and we've made our first repository, we can go into Morbius or any lab machine. I'm SSH'd in from an Ubuntu application on Windows. Alternatively, you could use PuTTY or something like that if you're on a Windows machine. So I've made a directory called February 3 demo. You could probably make a directory called like XINU homework 3 and put it in your COSC 3250 directory. But for now I'm doing this. So you'll see I have nothing in this directory now. And what we do is we go back to the GitHub repository we just created, and we have this link here, which is the link to your repository, same as this link up here. So you can also click this to copy it. And you go back, you do git clone, and paste that in, and it asks for your username, so your GitHub username that you just created, and your GitHub password for the account. And it says you have appeared to have cloned an empty repository. So that is correct. We did clone an empty repository, because nothing's in it yet. So if we go in there and nothing's in it, that's our empty repository that we just created here. So let's take a look at the assignment page, synchronous serial driver, and Dr. Brylow tells us about tar, which is a tape archive utility for Unix systems. You can think of tar as kind of like zip, if you've ever worked with zip files, or RAR files. It's just a grouping of files stored into one, what we call tarball. So Dr. Brylow tells us to execute this command, which will untar the TGZ file in his Brylow OS projects directory called XINU homework3.tgz. So we go back to our directory we created here, and this is, remember, this is within my XINU homework 3 repository, which I created on GitHub here. So I'm untarring it into my repository. So I paste, won't let me paste. Copy this, paste it in, press enter, and we have our XINU homework 3 files. So if you ls now, you get this XINU homework 3 directory. You can change into it, and ls again, and you have XINU files. So this is your XINU operating system, everything right here. So Most important ones, directories to remember are compile, include, and system. You're going to be in those a lot. So right away, let's change into compile and run the make command. So what we just did is we compiled our XINU operating system kernel. You could think of this as similar to GCC when you did GCC like -o hello.c or something like that. So in this case, you can think of hello as the executable, and the xinu.elf file is what's being linked at the end, and that's what's going to execute your operating system. So if this doesn't get linked at the end, you have some error in here that you have to fix up. These here are just warnings. You've probably seen those when you used the GCC command last week. So what we just did is we ran the ARM compiler command, which is make, to build our kernel. So thinking about that analogy I just talked about, the GCC analogy, you also used this .. and you could do hello to run your executable file you created. And I suppose the XINU equivalent of that, of running your kernel, would be ARM console. So when you run ARM console, what it does is it gives you a backend machine, which is a Raspberry Pi 3 machine, and these machines are located in that big black box in the systems lab, and there's a bunch of Raspberry Pis in them. I think there's about 14 or 15 Raspberry Pi 3s that run your XINU kernel on actual hardware. So it allocates a Raspberry Pi for you, an available one, and in this case we got Vervoid, and it says backend powered off and on. That's a power cycle, you'll see that. And then at the end here, it will be your XINU kernel. So as of right now, you don't see anything because you haven't written the synchronous serial driver yet, so there's no output here. So to exit the kernel when it's running, after you've run ARM console, to exit this, you must press Ctrl+Space, which gives you command mode, and then Q, which quits. So that's what powers it off, powers off the Pi. If you don't do this, the Pi will just stay running. And I've done this, I've made the mistake of doing this. It'll just stay running all night until someone realizes that it's on, and that's never good, because that's a machine that should be being used for other people who need it, like other students running their code. So you can't just press escape or exit or close out of your operating system window. That doesn't shut off the Pi. To shut off the Pi, you have to do this Ctrl+Space routine and press Q, which is quit. Okay, I'm going to run through a little scenario here. I have two terminal windows open through a program called tmux, which you can run if you so desire. So I'm in the compile directory, so I'm going to run make. And we get linking xinu.elf, which means our kernel is ready to run. So we run ARM console. In this case, I got Cyberman, which is a Raspberry Pi 3 machine. And when you're on ARM console, you'll always get a Raspberry Pi 3 machine that is available. And you can see kexecing new kernel, which means after this, your kernel is going to begin. So in the case of your synchronous serial driver, like I said, you can't see anything yet because you haven't written it yet. So there's no input or output. But once you write that, you should see stuff here. So in this case, I have a backend machine that's currently open because I didn't run Ctrl+Space Q yet. You can see it power cycles here. So if I do Ctrl+Space V and I go to this terminal and I run this command, xinu-status -c rpi3, you can see I'm on a Raspberry Pi machine and I've been on for 21 seconds. And this is actually updating, so now on for 29 seconds when I run it the next time. So I'm on Cyberman. It's a Raspberry Pi 3, which is class here, and it says how long a user has been on. So you can see this user has been on for 16 hours, 4 minutes and 18 seconds. Good thing I'm making this tutorial video, because then that person will know how to actually exit from a Pi, which is Ctrl+Space and Q. So just a note, if a user has been on for more than 10 minutes, so when this is 10 and this is 0, then you can run arm console, in this case mandrel, and it will actually give you that backend machine. So what we've done is we've kicked this user off because this user's been on for more than 10 minutes, and now this machine is powering on. So once we exit our execution, we can see when we run xinu-status again, no one's on it because we kicked that user off and we went on this machine and we properly closed it with Ctrl+Space Q. So we're in our compile directory still. Let's change back to our Git repo, and we know it's our Git repo because when we run ls-al, we see our .git identifier folder here, which means we're in a Git repository, and this is the root path of that repository. So we can run Git commands on this repository. So once we're here, we see we have this xinu homework 3 tarball, which we untarred here. This is a directory, and when we go back to our page here, where this is the origin of our GitHub repo, we don't see any code here. There's no xinu tarball here. There's nothing here, even though we untarred it. So what happened was we untarred it in our local copy of this repository, but we haven't staged any of the changes or pushed up any of the code. So to stage the changes, we run git add, and dot means current path, right? So that'll add all the changes and track all the changes you made in this Git repository recursively. So when we run git status after that, which is an optional command, we can see we have these new files that we just tracked with git add, and it says yes, we have all these changes that have been made. These are all new files because we just untarred into this new directory. So then after we run git add, we run git commit to commit our changes, which we just staged, and we can just call this initial commits. -m means message. So now it creates all these modes, and now we're ready to push. So the first time you push in a new repository, you have to run this command here. So you copy this command. It says git push -u origin master. So what this does, it sets the upstream branch for the master branch. So origin is where all the changes are going to be made. And you only have to do this once for the initial time. So you copy this command and you enter your username and your password. There we go. So it's compressing objects, writing objects. Always good to see progress here. That means things worked. And so now it says branch master set up to track remote branch master from origin. So that's what this command did. So you don't have to run with these options anymore. You can just run git push at any other time after this. And I'll show you how to do that. So now we've pushed our changes up. We can go back here. When we refresh, we see we have this xinu homework 3 repository, and it contains our xinu homework 3 tarball. And here it is. These are the changes that we made. So now I'm going to show you how to add your partner as a collaborator on your homework 3 repository. So for any repository, to add your partner, your OS partner, as a collaborator, so he or she can make changes, you hit settings, collaborators, and you type in the username, the GitHub username, or email address, or I guess full name, but just GitHub username of that person. So enter it here and hit add collaborator, and your partner will be notified via email, and we'll have to accept that invitation to collaborate. So now, let's say that I'm working with Brian, and so Brian has his own directory here, and remember I have my own here, which we already have. I have my GitHub repo here and my xinu homework 3 directory. So let's say Brian wants to get my changes. How does he do that? Well, he goes to my xinu homework 3 directory, which he'll have access to once I add him as a collaborator, like what we just did. So he'll have access to this, since it's private and he's a collaborator, he'll have access. Brian will click clone or download, and he can copy this link here, go back to his directory and do git clone, and paste it in and enter his username. So now what Brian has just done is he cloned my XINU Homework 3 directory, and he has all of the changes I made. So when he he has all my files, all my kernel files. So now that he has my GitHub repository, we'll run through a couple scenarios. So on my right, I have a representation of what my my local version of the repository will be, and on my left I have a representation of how Brian's would look on his own machine. So what I'm going to do on my right, I'm going to make a change. So if I make a change to our system kprintf.c file, and let's say I just have int hello equals 1, 2, 3, 4, 5, and I write and quit. So let's say I've just made that change. Brian does not have this change because he only has his local copy. I haven't pushed my changes, and he has not pulled my changes because there's nothing to pull. So on Brian's end, he's still up to date. So what I have to do is I have to push these changes, and Brian has to pull them. So now that we're still in our GitHub repository, I can do git add like we did before. And when I run git status, we'll see I've modified XINU system kprintf.c, which is correct. That's the file I modified. And when I run git commit -m after staging the change, I can say kprintf hello 1, 2, 3, 4, 5. Just a simple explanation of the changes you made in this message. And I run enter. One file changed with insertions there because I had a new line. That's why there's 2 insertions. And when I run git push, as for my username, password, and there, now that we've pushed it, we can go back, and when I refresh, it says there's 2 commits. So I have this initial commit here, and then this kprintf hello, which I just added, and when I click on it, it shows my changes that I made. These plus, green means additions and red means deletions in terms of code, lines of code. So, but when we go back here, Brian still has his same local copy, and he's only at commit, the initial commit that we made. So when I run git status, he has nothing to commit, working directory clean, because he didn't make any changes on his end. And when he runs git pull to get my changes that I just made, it says 1 file changed, 2 insertions. So now when Brian goes into his XINU system kprintf, he sees that change that I just made. He has my current up-to-date code. So I'm going to show you a demo of what a merge conflict looks like between you and your partner. So what a merge conflict is when you make changes on your end and you push them, and after committing them you push them, and you don't tell your partner that you pushed, your partner might think, oh, it's okay for me to make changes and push them because I'm up to date, when in fact your partner is not up to date with the current changes. And if your partner makes changes to the same file, same lines in the same file, then that creates what we call a merge conflict. So to demo that, I've made this quick repository. So a new repository here, just demo merge. So I'm going to just clone it like I showed you before, enter my username, and can change into it, demo merge. So I'm in my demo merge repository right now. I know that because when I do this, I get our hidden directory here, which means I'm going to get a repo, and I can perform commands on this repo. So when I go vim, let's just call it hello.c, and I just say something just simple, just some plain text here so you guys get the idea. And I'll say hello world. That's pretty simple. So I'll quit out and I'll add that change. And after staging that change, I'll do commit. And I'll just say hello world as the message. And I'll git push -u origin master, since it's the first time pushing to this repository. Enter my username and password. And now we've pushed. And when I refresh this, we get our hello.c here with our commit hello world, and this addition has been added here. So now that I've made that change, when my partner, let's just call him Brian, a name of another fellow TA, my partner takes this repo, clones it, and he remembers to put git clone in the front of it here, enters his username and password, and so he has demo merge, and when he looks inside it, he has hello.c. Oh, I like vim better than vi. And he has hello world in here. So now we're both up to date. So if on my end, if I were to make a change, let's say instead of hello world, I call it AAA hello world, and I add that, or stage as we call it, and commit with a message called a hello or something, and push that up, enter my username and password. So now I've pushed up this commit, and I look and I see, refresh the commit page, and I get a hello. Here it is. So going back here, oh, that's origin. Going back here, so we've just pushed this up, and let's say I am a poor communicator and I don't tell Brian that I just pushed. So now Brian thinks he's still up to date. In fact, he is not. And so Brian makes a change. Let's say Brian changes his hello.c file, and he has something like b hello world. And Brian is confident about those changes. He adds them or stages them and commits he commits BBB hello, that message, and Brian tries to push, and he enters his username and password. Updates were rejected, and it says the remote contains work you don't have locally. So what Brian just tried to do is make a change without pulling first. So if Brian had known that I had made a change, if I had told Brian, hey, I just pushed up some code, you got to pull before you make any more changes. If I had told him this, that would have prevented this from happening. But since I didn't tell him, we have a merge conflict here to resolve. So when we're on git pull, which it tells you to do here, to pull those changes that I didn't have, it's going to get kind of messy here. So we can see after we type in our username and password, it says automatic merge failed, fix conflicts, and then commit the result in hello.c. So when we open it back up, hello.c, we see we have this ugly code here, head, and this separating your changes from the remote's changes. And we have this commit ID here. So what I have to do is I have to consult with my partner. I have to say, Patrick, you didn't tell me about the changes you made, and I made this change. So now we have two changes here, and we have to decide which one that we're going to keep to resolve this merge conflict. So let's say we talk about it, and we both want to keep hello world A. So I'm going to just enter escape mode here in Vim and press D twice to remove my lines here. So we're going to keep A hello world. So I'll right click, and now we're back, and I add these changes, and I just say hello world fix up B, or I'll just call it A because we removed B. So we're fixing up our merge conflict, and I push that, here it's telling us that it succeeded. So we go back here. We see we have 4 commits here. So we have this BBB hello, which is the commit that I staged in the beginning, because what I did, I said, oh, my partner, I don't know my partner made a change, I'm going to make B. So you remember when I added and committed those changes, that was actually pushed onto my my commit stack here. And then here, when I changed it back to A, fixing this merge conflict, so now I'm now left with A here. So that's also pushed on to my commit stack when I ran the commit command. So that's why I have 2 commits here. So up here is the fix for that merge conflict. So all in all, this can be avoided by simply communicating with one another. So when you push, you gotta tell your partner that they have to pull. So now that I've pushed that up, I'm behind on mine, or Brian rather. Now that Brian has pushed his up, I'm behind. So Brian say, all right, I fixed the merge conflict. Now Patrick, you have to pull. So I pull, and I run. Type my username and password. There we go, and it says fast forward. You fast forwarded through the commits. So I went from here and I fast forwarded up to here. So now I'm all caught up, and if I go into my hello, I can see that I'm all caught up with that change that Brian decided to keep. So I just wanted to go over a few things as far as the assignment goes. So what you have here, as we've seen, we have kprintf.c here. So this is filled with to-do statements. So these are things that you are to do to complete the assignment. And with any of these XINU assignments, we're going to include for you this header file xinu.h, and if you ls, you'll see there's an include directory here in your XINU path. So let's just display all the possibilities here by pressing tab twice. So we have all these .h or header files, and let's look and see what's in xinu.h. So in xinu.h, we've actually included for you all the necessary files, so you don't have to worry about actually including things, because we've included it for you. But the one to keep note of here for this assignment is pl011.h. So this contains information about the UART device on the board. So if we go into pl011, we see here we have a structure of with all these fields, all these integer fields in it, and as well as these other pound-defined fields here. So just with any XINU assignment, it's very important to look around and see what you're working with. So that's my main tip here. And as well, you can, if you don't know, let's say, what a specific function does, you can run the man command, which means manual. So let's say in this case I want to know what getC does, because we're going to write the kgetc version for our synchronous serial driver assignment. So to understand what even getC does, which is its standard get character function, we can read the man pages, the Linux programmer manual pages, by running that command. We can scroll down with the down arrow and read this. So whereas online sources will get you somewhere close to the real answer, the man pages will always be 100% correct. So I highly recommend getting used to reading man pages if you have any other questions. So that just about concludes this instructional video. I'll put in the description timestamps so you can view specific areas of what I discussed here today. And yeah, I hope everyone has a good day.